Michelle, I think we're ready to go. Do you want to start with the introductions?
Sure. Hello, everyone. We see the attendees coming in. We'll spend a couple of minutes doing the introductions of the presenters. Some of you who have attended our series in the past, there are familiar names in the presenter panel and real knowledgeable people. The topic of discussion, as you know when you signed up, is shortest path from prototype to production. We have an expert panel to go over, in today's world, in the times we live, what is the best way to move from prototype to production? What are the things you have to keep in mind, and curveballs that are being thrown at all of us? How do we navigate that? On the expert panel today, we have Craig. Craig represents the Altium manufacturing team. We have Greg. He's the senior engineer at Xometry, and then we have Misha. He's our CEO at MacroFab. All of them, again, as I said, experts in their own domains, and I'm excited to get started.
Thank you, Michelle. So the topic we wanted to discuss today was moving as quickly as possible from prototype to production, but we wanted to put it in the context of the supply chain disruption, and in fact, a lot of the techniques that we believe are essential to moving faster are really not disconnected from what we're seeing from the supply chain disruption now. And in fact, the very same things that have always held you back from being able to move quickly from prototype to production, and a lot of it is waterfall behavior. We'll talk about that in the next couple of discussion points, is exactly what's keeping people back from producing anything at this point with the supply chain disruptions we're seeing, but the delays are being felt more and being measured in longer time frames. So we're going to go through each one of these sections, and we actually don't have a lot of slideware for you guys. In fact, between Greg and Craig, we have a tremendous amount of experience in the field and on the factory floor, going through the trials and tribulations of bringing multiple products to market and building products, sometimes with good design and sometimes with good production packages, and sometimes on a completely opposite end of the spectrum, just a giant fight to get a product to production. So these are the exact topics we're going to get into, and I thought there was enough experience and war stories between the three of us that what we've seen about what works and what doesn't, to where we're really going to talk about some of the headlines and some of the illustrative examples of why we believe this is the right way to accelerate your production path versus telling you about the canonical nature of and theory behind Industry 4.0. In fact, I think if we don't want to get Craig going, but I think if we were to start talking about Industry 4.0, he would tell us that it's a bunch of nonsense, and nobody needs to think, oh, he's got his picture of the unicorn already locked and loaded. But look, this is going to be much more about practically what you need to be doing in order to accelerate and also get around production challenges. So to very quickly state the sequence of topics we're going to talk about, I think one of the most important things is to be able to prototype and iterate quickly. And prototyping used to be something you did when you were first launching the product, and something you did after your design phase. At this point, we see people prototyping continuously, iterating. Not just, it's not just to get to a production package, it's also to pivot and be able to go to a different direction. In that sense, choosing your alternatives and making sure that those alternatives are pre-approved is incredibly important. We will give you plenty of examples and help you understand why that is. We're probably going to hear a lot from Craig, especially about developing a bulletproof production package, because I think that's one of the things that if you're running a factory floor, the degree to which you can actually execute really comes down to the quality of the data package you give to the production team. And I've seen handoffs that are literally hands-off, and some that require somebody to get on a plane and go down to the factory floor and spend meaningful time doing what is now affectionately known as tribal knowledge transfer, which is really just an indication that we're doing something that we didn't plan for and didn't anticipate doing, and the production package just isn't good enough. And ultimately, these are going to be new concepts for a lot of people, designed for factory portability, and just what factory portability means, why you should have access to it, even if you're not moving between factories, why it's important, and why that requires design level thinking to make sure that you can be portable. And finally, we're going to close out with what I think is going to be more and more important going forward, and that's reduction on reliance on maritime transport. We can't eliminate maritime transport. Supply chain is global, will continue to be global for a very long time to come. It doesn't mean that you can't compress major legs in your transit by not shipping at various stages, right? So we'll talk more about that and discuss what that means. So Michelle, if we can go to the next slide. This is something that we talked about in one of our first webinars. The traditional production process is really focused on doing things in a waterfall model, to draw a corollary to the way a lot of software used to be built. It's a lot of planning up front, a lot of interviews of the users, eventually big design guides get written, and you get customer feedback long before you produce anything. Eventually, you get to your engineering prototypes, you run your EVT units, 1 to 10 of them or so, just to see whether or not your functional design is even working. Your DVT phase really gets you to the point where you have almost fully assembled product, maybe a little bit of drift between what the mass production is going to look like, but really you start to test fit and finish, and you put the product in the customer's hands. Ultimately, you go to production validation, really test your process and ability to scale up, and only after that can you go to mass production. And that's been a tried and true process for a very long time. But while the software industry has moved away from waterfall methodologies some time ago, we are still very much married to this waterfall process. And frankly, it's no longer working. In fact, some of the things that are not working well is, first of all, there's 2 to 3 factories involved in the EVT, DVT, and PVT process. Each time you go from one factory to another, there's major contact switching costs. That's the reason why a lot of times you have to get on a plane and go retrain the factory in order and how to build your product, is because the production package isn't good enough. And for that reason, a lot of people try to cut corners, and what you see is some combination of choosing your mass production factory and trying to run prototypes on the giant production line, which never goes well, or vice versa. You choose your your low volume factory and try to scale up, and that doesn't work either. So access to multiple factories and access to factory portability is more and more important. Otherwise, you're looking at cycle times of 2 to 6 months, and that's being charitable. Sometimes it's longer than that, right? So this process just isn't working anymore, and there's a big reason why, and a lot of it deals with supply chain disruption that we're seeing now. So Michelle, can you go to the next slide? This is, and by the way, this is a survey that was done last year. And sometimes you do surveys, and we didn't do this one. This one's done by LEK Consulting, an outfit that I worked with before, and it was fairly broad. It wasn't just electronics, and it wasn't just mechanical world. It was actually across a lot of industrial operations managers. But even a year ago, they were predicting that COVID-19 is going to have a big impact on the supply chain. Even then, they were anticipating major shipping delays, major production delays. In terms of the semiconductor shortage, that wasn't happening yet. But already a lot of people were realizing that, look, when you cancel a bunch of orders and you try to restart them quickly, the bullwhip effect eventually catches up with you. There are people out there with plenty of experience. All of these risks really came to bear, and the situation we're seeing in 2021 was very much foreseen even last year. And the biggest question that we get asked these days is, when is it going back to normal? And we have a lot of discussions about this, and I'm not sure if it's going back to normal. In fact, I think at this point, it's a function of not just supply chain disruption, unpredictable shutdowns. In China, it's still very common to see shutdowns based on either COVID. And lately, it's been power outages. Every time China stops production on some of the materials, that causes production stops across the world, and now we're having a pile up in major ports, especially in California. A lot of these things weren't exactly predicted before, but now that the supply chain is out of alignment, I'm not sure if it's going to go back to normal anytime soon. The best minds that I've talked to about this say, look, expect it to be this wild at least through 2022 and well into 2023. And Greg and Craig, I don't know if you guys have any additional thoughts on that in terms of, do you think we're going back to normal anytime soon, or we just need to wait it out for a couple of more quarters?
Well, my end of the world, on the manufacturing side, I would say the prudent person is planning for mid-2023 and a tough first quarter of 2022, and then a somewhat linear improvement from the remaining quarters of 2022 into mid-2023. If I was still running a factory floor, that is what I would be doing, and I know a lot of my brethren and sister in that area are planning that way.
Yeah. And I just say, you're working with organizations that have to deliver product. Like I need to be a business and I have to deliver. So talking about those projections, if you have that level of redundancy or that flex, that runway to do that and project out, you could somewhat reestablish on this. But my thesis is that digital manufacturing just becomes part of it. It becomes part of the platform because it's agile and real time. I was thinking as an analogy, because you're talking about real-time substitutions, Instacart order or something like that, where an item's not in stock and you get a text saying you want this instead, and you're like, yep, sure, boom, and decisions made and done and fluid. And up until 8 years ago or so, that type of fluidity didn't really exist on any traditional manufacturing side, like the ability to really make those decisions until companies like what I represent, which is Xometry, which is the mechanical of the electromechanical systems, and then MacroFab, the electro part of that, if you will. Like those really did add a level of fluidity and agility and disruption there. And I think as our customers have seen their traditional supply routes get disrupted, it's they get hooked on how flexible and how dynamic these digital platforms can be. So I think even if it's not all of it, it's definitely going to be part of most major supply chains moving forward.
Here's another reason why I think it's not going back anytime soon. Right now, we're dealing with a lot of realities of the supply chain not operating as designed. And the way that the supply chain works now is you take, it's like a Jenga tower. You pull out a couple of pegs and things start to fall apart. But even if we were to reassemble and resequence the supply chain again, the thing that's not going back is the behavior change. We're talking about multiple years of a lot of volatility. And I think for that reason, there's going to be a lot of companies that go back and change the way that they do prototyping, change the way they go to production. I think we're going to see more companies, if not reshore to United States, but nearshore to Mexico. And at some point, even when everything starts to stabilize, at that point, you're dealing with your competition moving faster than you are. So the behavior change, once it gets triggered, it's very difficult to go back. And in fact, we saw this, as a history lesson. Today, when we think about cloud technologies, it's not, it's hard to imagine the days before the cloud existed, because I think, Amazon Web Services, I think, is over $30 billion. The second largest is Azure. They're almost $25 billion. I think, Google is big by themselves. Before 2007, there was no cloud, and it wasn't because the technology didn't exist. A lot of people think Amazon invented it. That's not the case at all. Sun Microsystem launched the first cloud in 2002. Mark Andreessen, obviously the original writer of Netscape, had a company called Loud Cloud, which is a cloud fabric they sold to HP. I want to say back in the days, I think it was 2003 timeframe. Nobody cared until 2007. What happened in 2007? We had a financial crisis, and all of a sudden, people had to re-examine the way they spend their money. And once financial crisis was over 2 years later, but we never went back. Right at that point, we were off to the races. So I think of this as a generational shift, just like a lot of companies are now working a different way, they're staffing a different way, hybrid work from home models are here to stay. I think agile manufacturing is here to stay as well. So we're going to get into what that means exactly and what we think are the moving parts, right? So can we go to the next slide, Michelle? So here's what I think is fascinating, and I'm going to go through a couple of points here. We're going to cover just 2 slides in one, and I want to hear from both Greg and Craig on this. But I think one of the big things that's going to happen is we're going to move from waterfall style slow iteration process to much faster prototyping, and especially much more continuous iterability. And partly it's because we need to be able to pre-approve alternatives. You guys know the headlines. I just put them up here because I thought it would be useful to see them up close. Look, the auto industry lost $110 billion in revenue this year alone. I think Apple said just in the last quarter, they lost $6 billion because they couldn't get access to all the materials they needed. These are products that don't have a lot of alternate parts available and can't easily just move to different set of suppliers just because they want to. So everybody had to cut their production. Honeywell, so we're seeing this in the industrial sector, autos, consumer electronics, everywhere, except for one. So go to the next slide. I thought it was fascinating that in the middle of all of this cutting production targets, Tesla, of course, goes the other way, and they beat their production targets and they actually deliver more than they've ever delivered before. And initially nobody really knew how they did it, and I think the conjecture was, well, Elon Musk must have hedged the market and just cornered the market on the chips that they needed. That's not the case. They rewrote their software from the ground up, and as usual, Tesla does things that nobody else is willing to do. So they were willing to go to their team and say, we're not going to miss our production targets. We are not going to get stuck waiting for Bosch and other chip makers. He's taken a couple of auto chip makers to task for not moving quickly enough. But what they did at Tesla was essentially rewrite their software and make it more modular and really simplify the process of pre-approving alternatives. So they were able to beat all of the expectations, and that's how Tesla ended up hitting $1 trillion market cap. I'm not sure if Tesla is really worth more than all the other companies combined out there, but that's what agility brings you. And I think that's one of the reasons why I think these lessons are just now entering a bloodstream. This is the only way to beat the supply chain crisis, right? We have a lot of customers that are doing redesigns very quickly, and because on our platform, on the same platform, they can do a redesign, turn the crank, reauthorize new alternatives. We can go to work and go source materials that are actually available for them. They are moving faster. Anybody who isn't able or isn't willing to do that is now stuck in the mud. So Craig, I know you and I talked about how important it is to have a design that's ready for alternatives. Is this what you've seen before as well in terms of slowdowns? And have you seen designs that actually allow you to move faster, where customers actually think about this ahead of time?
Well, Misha, as you know, I don't have much to say about this, but I do have my props. This is the world we want to be in, which all the material we specify is available. It's available when we want it, as cheaply as we want it. And this is the manufacturing floor. These are the bullets whizzing over the head of the people who have to build this stuff. So I do have more to say to that. And the bottom line is supply chain is always a problem. Ever since things weren't monolithic in one company, meaning not that supply chain people are bad or component suppliers are bad, but you're building a product that has thousands of different pieces of material in it that are coming from hundreds of different suppliers with dozens of different shipping methods and mechanics. That it ever actually works is rather amazing. Now, when you add today's problems to it, the key word you said, Misha, that both Xometry, Altium, and MacroFab are pounding on here is agility, right? We have to be able to realize that just because you specify a part that is available today when we got a quote and Arrow has 7,000 on a shelf in Arizona, doesn't mean when you place the order in 2 weeks, it'll still be there. It's like a commodity. The quote of how much and how long and how many is valid the minute you get it, and it starts getting old and immediately thereafter. So agility is absolutely critical, and the ability to pivot very quickly and do the best we can all the way from the design, when you're sitting in front of Altium Designer and choosing components and seeing that the part you've chosen real time with the Octopart interface says, hey, there's very few of these on the shelf today. That's the time to make a change. That's agile, right? The ability, if we get past that point and we're about ready to build something at MacroFab, and that part is no longer available, if we haven't thought about ahead of time, what are my other options? What agility do I have? We're giving the manufacturer that has bullets whizzing over their head. Those bullets are, oops, they go to place the order for the part. Sorry, we can't get it. The customer says, but you told me 3 weeks ago you could get some. Yes, 3 weeks ago I could get some, but I can't get them anymore, right? So that agility is just absolutely critical, Misha.
Yeah, my favorite one is where people can order the parts. It's like, well, look, nobody ever stops you from placing the orders. It does not mean they're showing up, right? And unfortunately, look, for years we were in a seller's market, in a buyer's market for components. When you placed an order, you were certain that it was going to show up. Not these days. There are a lot of times when materials are on order, we have a dock date, and we get a call the day before saying, you know what, somebody was able to pay more and we're just moving somewhere else.
I was going to say that, but I decided if anybody from Aero or Avnet was on the phone, they would send me a hate email. But just because we bought it at X, there are situations now where there's what's called MOQ, minimum order quantity, where before you could buy 5 of something and the manufacturer has 5,000 in stock, but there's people who want thousands and thousands of them. So the minimum order quantity becomes 1,000. You want 5? No problem. Buy 1,000. It's supply and demand. So we've got to be agile. And ultimately, there are cases where there's only one thing that will fit the bill. But the more of those you have, what we say in flying is if you consistently put yourself in a situation where your superior skills have to outweigh your inferior judgment, sooner or later, you're going to hit the ground. So we got to minimize those.
Yeah. And I think some of this comes down to the role of engineers, right? I think one of the things engineers desperately don't want to do is spend on, time doing unnecessary things. But here's where I think the trade-off really comes in. I actually rarely see designs where there are alternatives specified for every constrained component 5 or 6 deep. It takes effort, and especially if you have a rigorous testing process, now your testing process is a lot more complex. But it pays huge dividends when you get to the production floor. If you can give your manufacturer pre-approved alternatives, and at this point in our software, for example, you can specify before you place the order what the alternatives are. So we don't have to call you, we don't have to ask you questions. They're already in the build package, so the supply chain team can easily just go source things. What ends up happening though is we are seeing those same engineers end up having their time wasted by getting on a phone with the supply chain team saying, hey, we have a set of alternative parts. Do you think these will work? And they still go through that iterative process, but backwards, right? We're backwards chaining towards the decision, as opposed to at a design stage saying, look, there's certain number of parts that we think are going to be sensitive from the supply chain perspective. Let's go through the trouble of actually pre-approving those, making sure that when we run the, some of the boards that we build have to be baked in, and they have to go through environmental testing. These are long poles in a tent. When you got to do that when the materials are disappearing from the market within a couple of days, that's really what ends up getting people stuck. So I think more and more people are going to end up doing that up front. And I think ultimately the engineering team, and I think it's a good thing. I think engineers will spend less time doing useless work in the future, but I think there's going to be a lot more design level decisions made to make manufacturability more certain.
And I think too, when we're using these platforms, you're talking about the tools that you have on MacroFab site. So you're uploading your file and your BOM, and you're seeing some level of inventory and what you can substitute out for. But the most important thing there is that my entire medium of communicating is digital now. It is transferable. Like, so you have a tool that provides better visibility, but this isn't passing prints from one to the other, and it allows for like a much more flexible move. I know I work in the mechanical world, right? So I work in making the physical parts. And when we look at substitutions and alternatives, sometimes that's, if I'm doing molding or something of that matter, it's usually a resin selection, especially if you have different origins, because some materials are much better available, in China versus the US and vice versa. And I've always had the fantasy as well of creating what I call the 50-pound bag store, which is a lot of low volume manufacture where you don't need to buy in the injection mold world, we call them gaylords. They are essentially, imagine a pallet cubed full of resin. And a lot of times when you're doing a low volume iteration, your first launch of your product, you're not going to use that much material. So our other part of flexibility often has to do with how much supply base we have. Is there on-hand material that we can work with? Do we have substitutes in mind? But it's much more about the flexibility from our supplier base, as well as even things that you could just do digitally. So like behind me, we have options, right? When we make parts, I have a bunch of ways of producing that based on that holy trinity of like time, scope, and cost. Choose two, at least on those early phases, as you're narrowing down your scope on, and to your point, figuring out how you're ultimately going to produce this and remain flexible.
And Greg, in the mechanical world, I actually had a question. There's obviously a lot of supply chain constraints with both just PCB level electronics production, but especially when you get to final product assembly, they're just parts that are not always available. But has that impacted mechanical parts production as well? Because I know some of the shortages have just been purely on raw materials, and that's been very surprising to see. I don't think anybody anticipated that.
So it's kind of a yes and no. Like sometimes I can work with alternatives, and we've been finding large organizations being much more open, especially in the last 2 years, to listening to that, because they may have a specific, especially when we talk about going towards a production like a molded resin, something in mind. And us being able to offer, saying like, here's the spec sheet of this material that I can readily do to run this project on. Here's the outcomes that we expect from it, and allowing the engineers to make a decision has really helped. Honestly, speed up sometimes by months, just because you're waiting. I noticed, gosh, was it 6 months ago, or urethanes were actually very tough to secure, and we saw some, we had to put our supply chain into action, and luckily we do have a whole team that focuses on getting raw, finding raw
The craziest thing we
materials.
saw with one of our customers is we actually could get all the, and by the way, to clarify, with MacroFab, we don't just do PCB assembly, and we absolutely help a lot of our customers. Just like with Xometry, you can go upload a design, you can spin a PCB quickly, and you can do it in as short as 10 days, and so you can rapidly prototype on our platform. But a lot of our customers end up going to production, and in fact, we actually source all of the E-BOM, all of the mechanical BOM materials. We will source all the consumables. We actually will, we have in our network, we'll talk about the networks that Xometry and MacroFab have, but our network is all about factories that do final product assembly. So the craziest thing I saw was customers getting hung up, not on semiconductors, that's in the news. What wasn't in the news? Epoxy. We couldn't buy epoxy for months.
Anything that's compounded. Yeah, absolutely.
So, like you said, polyurethane was gone. Silicon was gone for a while, and that was in the middle of COVID shutdown. So commodities seem to have settled down. At one point, there were doomsday scenarios about copper. Copper prices spiked up, and all of a sudden, the PCBs just went through the roof, and every PCB essentially went, for a short time became 50% more expensive, especially if you were laying, heavy copper layers in it. Seems to have stabilized, but this is the thing that I keep thinking about is if the infrastructure bill passes, it is packed to the gills with electrification of cars, which means a lot of batteries and a lot more cars, car production, which includes semiconductors and a lot of solar projects. So I think commodity crunch is probably in the cards for us in the future as well. We're talking about, trillions being spent on some of this stuff. That's going to cause a supply chain crunch at some point.
Yeah, and I've seen so sometimes there's new technologies that are getting more exciting. As you see these crunches, we're talking about epoxies and potting compounds and other materials. I've seen some really neat technologies recently with essentially low pressure injection molding that you could typically you can't overmold on a PCB or like in like something that's very sensitive because the pressure and the heat and everything involved, particularly the pressures. But there's some newer technologies that may create another option, right, for outside of using an epoxy for that application.
Yeah. So Michelle, can you go to the next slide? There's another interesting case, and this one kind of came and went, and I know Greg had personal pain of having to deal with this because we ended up not needing a lot of ventilators, but there was a point in time when we thought ventilators were going to either just save the humanity or destroy it. So a lot of big things happened, right? The president invoked the Defense Production Act, and all of a sudden you started to see Ford retrofitting their auto plants to build ventilators, which really didn't make a whole lot of sense for me. What would have made sense is upload your design to something like Xometry, because a lot of ventilators are really mechanical parts with very, very small electrical components attached to them. But that's not what ended up happening. And I saw this note months ago when this was happening, and I always thought it was fascinating. I guess it was over a year at this point. I was blown away that in the middle of Ford moving mountains to go produce ventilators at high scale, what did they have to do? They had to go get a ventilator from one of I think it was literally donated by a ventilator company. How did they start their production process? By 3D scanning all the mechanical parts, which blows my mind. I mean, if this is a going concern product, why would you have to go 3D scan it? Because ultimately it would have been trivial just to upload it to Xometry and start replicating parts in a network of, you guys have what, 50,000 machine shops and injection molding shops. But what really was holding this up was really a production package that wasn't ready, right? It was being built at some factory, and there was some factory that knew how to produce those parts, but a design was obviously not staged in a way that could be scaled up and replicated, right? So I thought that was fascinating. We see that in electronics world as well. Lack of a bulletproof production package to actually go to production is one of the biggest delays, actually. So look, none of you can stop, none of you can create materials out of thin air, but developing a better production package, that is well within our powers, right?
Yeah, and I was just going to say, one of my largest critiques, and I hope that we're better prepared in the future, is like for a lot of these products, and we saw hundreds of these type of like ventilators and PAPR and BiPAP to ventilator conversions, and you name it, like hundreds of these things. But to your point, a lot of them were fresh inventions. There's not a hard R requirements document saying from a medical standard, this is what's required to do this. Everybody was kind of learning on their own, and something that I think will make our nation more resilient, and just in general, like it's something you could apply. And I love your phrase here, factory portability, is that your virtual package, that digital package, is just as important as the physical part. Because you're right, they could have moved. You had to wait till it was an emergency, and then you start your reverse engineering effort. And it was really difficult and challenging on our side because we had the capacity of manufacturing ability immediately available, and the delay was the discovery. Like, oh, I'm in a bind, now I need to start my discovery process and go through traditional steps of creating a product.
Yeah, and Craig, you ran Rocket EMS for a number of years, so I know that for a long time you dealt with the high mix, low volume world. Tell us more about the production package challenges, because I'm assuming you've seen it all, everything from kind of immaculately designed products to things that just weren't ready to go to production, but the customer expected it to go, right?
So I'm hoping in one webinar not to make every component supplier, every chip OEM, and every engineer hate me. But I want to show you the list of, or the graphic that correctly explains the number of times in manufacturing, and this is over 3 manufacturing companies, combined revenue of probably $500 million when you add them all together, where we get a package, the bill of materials is correctly and accurately specified, and the material is generally readily available. The data is error-free and clear and concise. The requirements are achievable within reasonable manufacturing guidelines, and et cetera. How often do we get that? Put it through dot control and DFM in the factory and produce a product. The unicorn. So never. And I'm not saying engineers are sloppy or dumb or make mistakes. Everybody is under just critical pressure to get stuff done quicker. They just released a new iPhone, and a day later, there are blogs that are talking about the next iPhone, and they just released the first one, right? The product pressure to get stuff done.
Yeah, and Craig, I actually don't think, so I don't think of that as an engineering or supply chain problem. I think it's structural in a lot of ways. And, I'm guilty of making way too many analogies back to my cloud days. But frankly, until we move towards DevOps, right, where the engineers owned uptime, none of this actually started working right. And moving between data centers used to be a monumental project, right? And why? It's because the people that wrote the code were different from the people that loaded the code on the servers. And those people that loaded code on the servers, their favorite pastime was kind of managing their servers like they were, like they were godlike entities and comparing their uptimes. And that's not really the way that, you can't move between data centers that way. Same reason you can't move between factories that way either. So part of the problem, I think, is structural. A lot of what we get inbound from our customers, the process looks to me like an engineer designs the product, not one engineer. There's usually 3 engineers. There's somebody who's responsible for the firmware. There's somebody responsible for the electronic design, and somebody for the mechanical part. Sometimes more, right? They collect all their files into a zip file. The BOM gets attached by somebody in purchasing, and it looks like a Frankenstein list where lots of things can go wrong. At the end of the day, the person that actually sends us the design files is probably a person that doesn't know much about the design at all. It's not an engineer. It's usually a low-level person, and it's a low-level buyer. And what we end up doing for the next couple of weeks is broken telephone. Hey, this doesn't make sense. There are parts that are literally cannot be placed on your PCB. Do you know why? Usually the purchasing person doesn't know why. They didn't design it. So what happens next is a very large conference calls with a lot of people on it. That's a structural problem, right? As long as we keep treating this as a purchasing exercise as opposed to an engineering exercise, right? Putting a design package on the factory floor and assuming that it's got to get stood up and go to production without a lot of drama, conference calls, and having to go through tribal knowledge transfer. If that's not a core design requirement, we're going to keep on being in the situation where we just can't move quickly enough, right?
Well, Misha, yeah, what you described, the word waterfall or serial and the word agile, and if you look at what happened with cloud computing in 2007, as you pointed out, when it flipped, it didn't flip slowly, it flipped. And there's no way we're going back. Well, the design tools, the electrical design tools like Altium Designer and Altium 365, the Xometry design tools, the MacroFab process, what is that all trying to address? Not designing in a waterfall way, but creating this agile process where things are all happening at once and you're getting very quick feedback. And how do you do that? You have to do that digitally. Where do you do that digitally? AKA the cloud, right? You've got all this stuff connected real time. So APIs are going to pull information and giving the designer, no engineer has the time to be a supply chain expert, a mechanical expert, a part expert, a cost expert, a manufacturing expert. So what do we have to do? We have to bring that expertise into the digital domain and deliver it to the desktop. And that's what we're doing, all of us.
And I know that's what's really exciting about, you know, this group that we're here is like we're all reaching down to that design phase. So not only do you have the platform, right? You know, like for the platforms that we all work on, but we're going into design tools. For example, like I work in CAD. You know, I have CAD, like Xometry has CAD add-ins, but it's unique because some of these add-ins you actually have better DFM feedback than you have on our site, because that's when you're making the decisions, right? That's when you're adding the radii. That's when you're carving out the piece, and you can make those active changes to get a better product downstream. So like it's just really exciting to see the tools that the designers, the engineers are using are actually there to help them. They're not just something to help facilitate, you know, to get a digital print or something. They're actually there to help create a better outcome. And it thinks about the manufacturing end while you're still, you know, moving around shapes, and it's really cool.
And one thing to be clear about, first of all, this shift is painful, but it's very much worth it. But we're going to see this in the hardware world as well. There's going to be battles about who wins and who loses. And when I say engineers have to be central to this process, I don't mean that we got to go get rid of the supply chain team. Like Craig said, engineers will never understand the complexity of the supply chain world and the complexity of sourcing materials. I'm not actually talking about a particular job. I'm talking about how things work. And this happened in the cloud as well. At one point, DevOps became a job posting and a promotion. And it's not a job. It's really more about the culture that you build. And you know, ultimately, these people have to be part of the same team, and they got to operate in an agile way. But you can rechristen your traditional team agile, and nothing's going to change, right? If you don't replumb your process, and especially if you don't look to eradicate things that slow you down, right? Like if your natural inclination is, well, obviously nothing ever works until I buy a plane ticket and go fly down to the factory. Nothing ever functions properly. That's usually a crutch for inadequate design and inadequate production package. So that should be an indication that something's wrong. And I think, you know, people like us, we're not sitting here to complain about it. We desperately want to be able to help people do that. In fact, I think as an industry, we move to a much better place if we move to more of an agile development and production process. So we have a huge role to play in this, and a part of it is helping people figure out how to build this right. For us as a manufacturer, that comes down to actually owning the testing process. We may not necessarily build every fixture, but we haven't launched this yet, but we're going to be launching a set of cloud services for test data collection, because that's going to be, telemetry from your manufacturer being able to be collected and staged in a way that can be reportable is going to be an essential thing that has to happen in the future. And that's a role of us as a digital manufacturing company that we're going to fulfill in the next couple of years. So Michelle, let's go to the next slide. The last topic that I really wanted to touch on is, and this is that, the supply chain disruption today is really ebbing and flowing. At one point, it was just pure materials availability. At this point, it is still materials availability, but now what everybody's hearing about is the crazy situation we have at the ports. What a lot of people don't realize is that it's actually been going on for some time. We started to see, it's not just a pileup in the ports. The cost of transport has spiked dramatically. It used to be $3,000 before COVID. I think it was $3,000 to move a container from Asia to North America. It spiked out to about $5,000 in the middle of COVID, and now it's like people were literally sitting there thinking, it can't be over $15,000. I just got to wait it out, and it's going to come down a bit. But it's tripled since then, right? It's really come up to about 25, 26K at this point. And the place where it's having the biggest impact is twofold, right? One is if you're doing finished goods assembly in China, especially, chances are you're having trouble getting the product out of China. But if you're lucky to get it out, you're paying much more for it than you used to, right? So what a lot of people don't realize is that North America actually has very inexpensive labor options at this point. Mexico has lower cost labor than China. So we've seen a trickle of people realizing the fully landed costs in North America are actually very competitive with China even before COVID. At this point, I think my recommendation to everybody is, look, it's not just about US, it's really about thinking about access to best labor you have on a North American continent, because we're always going to be sourcing materials from Asia, but it doesn't mean that we have to build finished goods in Asia and have fully packaged products stuffed into containers having to be dragged across maritime routes for 6 to 8 weeks, right, which is actually much longer now. So it's not a surprise that Peloton moved their final assembly to US. We're seeing a lot more companies still source globally, but really do final assembly either in US, Canada, or Mexico. Right. And Greg, I think you guys were ahead of this trend as well. I mean, I actually distinctly remember Xometry, a lot of Xometry marketing was all about American manufacturing. There was a lot of American flags in your, I used to be hounded by Xometry ads on YouTube, and it was all about American manufacturing.
We're not giving enough ads. I'll double our efforts. Yeah. Anyways.
But I think the perspective of agility is healthy all around, and I suspect you have a lot of customers that are saying, in terms of getting the product in their hands when they need it, they are choosing North America more often than not these days. But sometimes the flexibility of having to be offshore is still important. And for us, the exact same thing, right? We have factories all over US, but for high volume manufacturing where we got to be truly competitive with China, Mexico has been a phenomenal option. And what these digital networks, they really matured over the years, right? Initially, digital manufacturing started out as a digital interface to a traditional factory, sometimes just one factory, right? There's still digital manufacturing companies out there which essentially, are supported by a single factory somewhere, right? Yeah. But the wave of the future, I think, is enabling nearshoring and especially factory portability, right? Working with these digital platforms, one of the best things about them is that you can actually have seamless migration between low volume factories and high volume factories, really matching up different SKUs with different factories or different lot sizes, or even going in parallel, right? We have a lot of customers that are now saying, what if I got to get big and I got to go compete with somebody huge? And, do I need to go to Asia at that point and interrupt production for 6 months? No, the answer is we have 5 factories in Mexico working for you, not 1, right?
And we found the same things. Like it's always it's kind of like that meme, like why not both? In a lot of times, so we do definitely have a distributed manufacturing in the U.S. It's still 3,000 shops, right? We have especially on the machining side, sheet metal fabrication, tool and die. We have shops dispersed across the U.S. and we do have some entities out in Mexico as well. It's interesting because Europe's a great analogy. Xometry Europe was done through an acquisition of a company called Shift, and they already had production in 18 countries, and that included countries from Spain to Eastern Europe, and you actually could get different economies there. And we're also, to your point, from a price point, sometimes it just makes sense to use Asian manufacturing in China, and we have those options. And at least for the customers, they're working through our digital interface and they're talking with people on their, with teams on their own time zones. So we're managing that portion of the supply chain, and I always like to say, like, we're creating positive outcomes. Like we're doing, if there's a supply chain disruption or something that we are troubleshooting, our team is able to forecast, and we have alternatives already lined up in those regions to really remain flexible and agile for our customers without them having to get online and run like a broker, for example. So yeah, geographic dispersion is just huge, and manufacturing networks let you find those sweet spots, the production manufacturer, the job shop, the parts in between, the people who really like to do this sort of material, and get pricing that makes sense for the sweet spots too, without really having to go around and do that searching. It's just powerful.
This was a topic of big debate in the cloud circles for a long time as well, because now we know that hyperscale cloud companies with the biggest networks of data centers are the big winners. But 5-6 years ago, still we were talking about multi-cloud and a lot of concern about having all your eggs in one basket. and ultimately the network effects win out. And some of it is just purely practical, right? If you can be on the same digital platform and turn your prototypes and then very quickly go to production and scale up to much higher volumes, that's much faster than having to go context switch, even between the different digital platforms. We still don't see people, kind of seamlessly hopping between Azure, Google Cloud, and AWS. That's not a thing. People, choose a network environment, and they usually gain access to a lot of resiliency with a single digital platform. I think we're going to see the similar evolution in a digital manufacturing space as well. So the network ultimately is what wins. And the more factory capacity you have access to, the less contact switching you got to do. And ultimately, it's worth it having your engineers on the exact same environment as your supply chain and production team. There's some companies that are large enough to have production engineering teams, which is yet a third team that needs to be plugged in. Collaboration on the same platform between all those three teams is essential, right? So, Craig, a quick question for you. You've been long enough to probably hear the predictions that there's going to be a nearshoring or reshoring wave multiple times now. Do you think it's happening this time, or is it another false start?
Short answer, yes. And it's not a tsunami. It's not a tsunami, and it didn't just start with COVID, but all of the things you've been talking about, $25,000 shipping containers. Look, the fact of the matter is silicon is going to be produced predominantly in Asia for the foreseeable future. The amount of investment required domestically to make billion-dollar factories, that's not something, even if the billions were available, you just snap your fingers on. So, but yeah, the swell has turned into a little bit more of a wave. It's not a tsunami, and I wouldn't expect it to be a tsunami because, frankly, the manufacturing capacity we have in North America isn't ready to take a tsunami, right? But yeah, short answer, absolutely. Absolutely.
Yeah, I think that's a great point. I don't think it's binary as much as things are finally set up for the rebalancing, and that rebalancing is going to be incremental. But I think the other thing to note, and I was surprised by this when I did my research into it, this doesn't count the mechanical parts market, right? We're talking about just electronics manufacturing and just the outsourced electronics factories. It's about a $600 billion market, and North America is more of it than you would think. It's about $120 to $140 billion. So there's actually quite a bit of, quite a few factories, over 2,500, I want to say, in North America alone. So there's actually a lot of capacity here, and a lot of people think, everything moved to China a long time ago. That's just not the case. There's actually a ton of capacity on this continent, and I think that's going to be like, for example, I don't think Apple is going to move to North America ever, right? The too high of a volume, then you have access to just a lot more people. Like, I don't think we have enough humans on this continent to build enough product for Apple, right? And that's fine. We're talking about mass production consumer product. But when you're talking about medical, aerospace, and defense, especially, that's what's already here. Industrial technologies, right? A lot of what's really being built now, and that's really where the innovation's coming from, is drones and electrical cars. That is actually the place where I believe, and it's not just U.S. I think it's really the USMCA corridor where the intellectual property protection is much better, and there's a lot of factory capacity that you don't. It's not easy to go find it, but it's out there for sure.
And frankly, there can be products with a user base of one now, with access to technologies and what's available. And you're also seeing rev changes happening so quickly that, yeah, it may make sense for iPhone, which is massive distribution, where it has to stay in one location. But a lot of work, because the nature of it has a quicker time of production before rev changes, where you're tooling up and doing something else, is great for these flexible, smaller I should say smaller supply chains, but smaller companies across a digital network. And I think the number for shops in the US, like small business manufacturers in the US, is somewhere around like 260,000 shops. So there's a lot of capacity, but what isn't there is visibility, right? That the handshake, like knowing that person there in Utah or California, Oregon can make my product. And that's again, like going back to what we do, that's what we do very, very well, is make that connection. Yeah.
Right.
So guys, great conversation. I have a couple questions from our listeners. Interesting one. The first one is, in the current scenario where supply chain is disrupted, would it be a good practice to keep parts and do prototyping in-house at the company level rather than outsourcing, keeping the fact in mind that we have to adapt for some alternative part?
Yeah. I'll chat really quickly on the mechanical side, because that's easy. A vast majority of our customers have some level of in-house manufacturing, even if that's your desktop 3D printer making some parts as you're iterating through. I love it. It makes you better. Like it makes you better at design and concepts. But what you may not have is the variety, the material access you're looking for, size constraints, and just capacity. And so that you still will be often utilizing digital platforms. But I see it hand in hand. Most of my customers I speak to have some way of mocking up a shape. It may not be how like the mechanicals that they're looking for, but it gets them a little bit further in the iteration.
Yeah, and on the, I'm sorry, go ahead.
Yeah, go ahead, please.
Yeah, on the electrical side, unfortunately, we can't go on Amazon and order a $350 3D printer to make electrical circuit boards. So the capital cost for companies, and remember in the 70s and 80s, IBM and all the manufacturers who made products, many of them had substantial in-house manufacturing, electronic manufacturing capability. And that's
2/3 of manufacturing is still done in large companies, right? In their own facility.
So, but the reality, no, I don't see a solution in the time frame that we're talking about, mid 2023, where companies would bring back electronic manufacturing and any kind of production capacity. I don't mean volume. I mean with machines that you have to buy that cost $250,000 a pop, just to build 5 prototypes. There's enough capacity, as Misha pointed out. There's plenty of capacity in North America and the US and specifically. What we lack and what we're all bringing to the party is a digital connection with all of that to distribute it for the need. So no, I don't think it's
that was going to be the thing that I mentioned. Even if you can do it in-house, especially for something that we do at MacroFab, we take customers from tens of units to hundreds of thousands of units in production. That digital package, the root of it is the PCB design that gets uploaded to our platform. So iterating on that in a different environment is counterintuitive. But the real answer is it's also an evolutionary dead end. This is something that we actually don't talk about it much, but historically, MacroFab originally got started with the dream of building a tabletop pick and place machine. When you have a couple of engineers and they're sick of dealing with manufacturers, what do they want to build? They want to build a 3D printer equivalent of their garage factory, right? The micro factory that they can just play with. And we're not the only ones. We have competitors that did the exact same thing. Not a single one of those products really came to market in a meaningful way. It's too hard to build, and nobody really wants it long term. So the desktop pick and place idea, I think, is dead and buried at this point.
And a lot of that is around technology too. It'd be great if everybody could fly airplanes, but just getting in an airplane, you don't press a button and say, fly me someplace. There's actual expertise required, and I'm not discounting 3D printing, which is amazing, but nobody's going to use a $300 desktop 3D printer they bought on Amazon to build a production part. So on the electronic manufacturing side, there's so many process steps, so much complexity, that unless you're going to get a soldering iron and solder in a few parts and build 1 or 2, which sure, you can do that. But anything beyond that, the expertise level is pretty deep to be able to do that.
Yeah, for alternate parts, be able to swap out a couple of components and be able to bench test them, different story entirely, by all means, right?
So next thing, sorry, the last thing I was going to say on there is, one of the beautiful things is, next day air still gets it there tomorrow. So even if you're on a rapid timeline, if you're working with network, there's expedite options are still super readily available and often work within your own production schedule. So like regardless of where it's produced, if you know, and I think that's something that some people think there's value in the time that I have if I could build overnight myself, but I could also overnight ship to you.
We're up on time, guys. Great discussion. There is one more question that we actually have.
Let's do it.
Yes. Go for it.
All right. So the other one says, what are some suggestions and key practices a startup should adopt in order to have a better workflow when it comes to PCB and mechanical parts fabrication? So suggestions and key practices for a startup.
I think it's it's really integration with your production partner as soon as possible. I think from that perspective, you may not be going to production anytime soon, but the sooner you establish that conversation, you'd be surprised how many of the design choices become a dead end. You gotta, you paint yourself in a corner, and now you gotta go backwards, right? So I know we talk a lot about digital technologies a lot, but guess what? When you're doing secondary assembly and when you're doing programming and testing, there's engineers involved from our team, and they're ready to help. And I think that's essential. Unless you're building kind of one-off projects, early engage. And, from that perspective, like a Chinese quick turn PCB fab doesn't help, right? That's not who's going to build volume for you, right? So early engagement, I think, is very important.
This is me speaking. I don't know if anybody knows about the Lorax from Dr. Seuss. He speaks for the trees. This is me speaking for every manufacturer, big and small. We're begging you, get us involved early. We want to help, really, please.
Yeah. They said it fair enough. And by the way, check out our sites for design resources too. Like we come from experience, we try to teach that. So I think each one of our respective sites actually helps you learn about a process and why you may use it over another. And those are just as valuable as the actual production portion because it helps make you better prepared.
And by the way, it's not just us. There's a Slack channel with 600 engineers hanging out on the MacroFab Slack channel. So the community is there as well, and you'd be surprised how often the lessons come from our customers as opposed to us as a company, right? There's a lot of people collaborating, and sometimes they talk about their dogs and what they had for lunch, but sometimes it's like real existential design questions,
So on that note, guys, again, appreciate the discussion. There are a few more questions that have come in. I think the best way to answer this would be we reach out to them personally and send them an email. To Greg's point, all of us have a really informative site. So go to Xometry.com, Altium.com, MacroFab.com. I'll be reaching out to the attendees and the people who actually registered with all the information, with all the 3 websites, resources that you could use, the Slack channel Misha mentioned. So you have all the information at your fingertips. You will be able to hear this webinar on demand as well within 24 to 48 hours from today. So I'll send you all the information in an email, and looking forward to seeing all of you in our next webinar. Thanks, everyone. We'll sync up later. Bye.
Thank you.